Hi, Professor Valvano. How are you doing today?
Totally sweet. What's up?
Good. I have a question about Lab 2.
Okay. Something in specific you want to start with? What?
Not really. I just have no idea what's going on.
Okay.
Step 2 especially.
Yeah, all right. So let's look at step 2. This is what it looks like in the lab manual. And let me ask you a hard question, Elise. Do you know why we're doing this?
Not really.
No, okay.
No idea.
So as we saw, no problem. As we saw in the last video, we dump to make a recording that we can put in our software documentation to prove that it works. And as you remember, dump records both the value and the time, okay? And so one of the ways to understand what we're doing in step 2 is focus in on what does J mean, okay? J in this testing of your testing is a virtual data port, an I/O port, either input or output. And so if you look at the values of J, what will they be?
0 through 7?
0 through 7. So I have a 3-bit I/O port with the bottom 3 bits. And the other thing that's happening here is if you run this a second time, third time, fourth time, what will be the values of J every time I run this program?
0 through 7.
Yeah, always the same. That's got a fancy word. It's called stabilization. Ooh. Stabilizing means I can run the code over and over again, and I have the same data. All right? So J represents the data I'm recording. And so if you were to visualize the 3 bits, how is bit 0 different than bit 1 versus bit 2? How are they different?
Well, bit 1 is going to change every single time. Like it'll flip-flop.
Yeah. Yes.
Whereas bit 2 is going to change a little bit slower, I guess.
A little bit slower. Come on. How much slower?
Twice as slow.
Twice as slow. There you go. You got it. Okay. So if you were to imagine the sequence, I'm writing it in binary, obviously. Okay. And look at the 3 bits. And what about bit 3?
Twice as slow.
No, bit 3.
Oh, wait, yeah.
Bit 3.
Bit
Not bit 0, bit 1, bit 2. What about bit 3?
Bit 3 is not changing.
It's not changing at all. Okay?
Yeah.
All right. So the bottom 3 bits are changing. And the rate at which they change is going to double every time I go up a bit. Okay?
Right.
And so again, I've stabilized this. And do you know, can you guess how much time is going to elapse between the recordings?
It looks like 1 millisecond.
Yeah, 1 millisecond. So if I were to put another label on here and call it time, that's going to be 0 milliseconds, whatever, 1. So every millisecond, I'm going to have another, if this column here is a millisecond. This is the data pattern that I'm going to get. What happens, not while I'm getting there, what's going to happen when I get to 7? Can you see the code?
The code after you get to 7?
After 7, what comes after 7?
It looks like the loop for J starts over.
Yeah, but what about time, though?
Time keeps going the same way.
Yeah, time's going to go, right? So if I were to look at this all together, right, and if I were to see it, what's is my expectation, right?
Time's just going to keep increasing.
So how many total recordings do you expect to have in this program here?
After running this one?
Yeah,
16.
16. Okay, that's what my data said. All right, so the idea here in this section is for you, this is what we thought would happen. And now we're going to run the code and see what does happen. That's what debugging is. So let me show you. Okay, let's debug it and see what happens. Okay. Now again, it's going to, in 16 milliseconds, it will collect 16 elements, dumping it into the array. Okay? There's a number of ways to look at what we have. Okay, so I'm going to run the code and fill up the arrays. Okay, so 16 milliseconds later, it's all the way down to the bottom. Okay, one way to do it is to add a watch window. Right, so right here, if I put in data buffer, okay, it knows how big it is, it knows everything, and I can see data buffer. I can look at the time buffer, spell it right, and I can look at debug count, right, which should be 16. Yeah, that's one way to see things. Another way is the memory window. So I go View, Memory, okay, and I can look at the contents of the memory. Now I can do it with absolute addresses, but in C I can look at it by using its symbol here. Okay. Now over here I have to place in the type. And what did we expect the data values to be?
We expected them to be 0 through 7.
0 through 7, and then
0 through
7 again, and that's exactly what we got. All right. Now the time is weird. Those are big numbers.
They don't make a lot of sense.
They don't make any sense to me either until we subtract 2 of them.
Oh, right.
If I subtract 2 adjacent numbers, I'm going to get a millisecond, by the way.
That makes sense.
But let me show you how to do it without a lot of fuss, okay? And that is this guy here, okay, is export data to file. One way to see all of my data is to take it from the MSPM0 and put it on my laptop. That's what I'm doing here. I can type in an address. Over here I see, what's that 2020-0200? What's there?
That looks like an address.
Yeah, but of what?
The data buffer.
Yeah, the data buffer. Okay, so how big is my data buffer? I know it's 50, but I only need 16 elements, okay? All right, so that's my data buffer. What's at 2020-02C8?
The time buffer.
Time buffer. And how many? I want 16 of those, okay? And so there's a lot of choices here. It turns out text is the easiest one to process. So I'm going to change the text, and I'm going to give it a name. Let's call it data text, and let's see where it's going to put it. All right, right there in my lab. Okay, so I'm going to data text, save. Okay. All right, okay. So what it did is it dumped onto my computer that information that I need to process.
This all sounds great, but is there a way to look at the values in Code Composer Studio?
Well, we can see them here, but we want to put it in our lab report. So yeah, that's why I did it. Let me show you how to do it. When I issued that dump, I got this file right here. And if I were to open it up, there's this weird and wacky and nobody can understand information that I dumped from the computer. But luckily, Dr. Yarabali came and saved today. So I'm going to do a copy on this. Okay. And then I'm going to open up the Excel file that Dr. Yarabali gave to us. All right, this is the file that Dr. Yarabali gave to us. In this yellow part here, I'm going to remove and paste in the data we just collected. Okay.
Does that mean that we have to save the data buffer and time buffer in a specific order?
Ooh, yes, absolutely. The thing we did in terms of which is which, we did the data buffer first and the time buffer second, because that's going to decode this raw binary stream into the data values, and the time values, now they're no longer in hex, they're in decimal for us humans.
That makes sense.
Yeah, and you remember, what did we expect to be in the data buffer?
0 through 7 twice.
Yeah, and now this is exactly what we got.
Okay.
Now, if I were to take the data number and I were to AND it with the number 2, what am I selecting? If I take this 2, if I take this data value and AND it logically with the number 2, what is the significance of this column?
That looks a lot like the bit 1 value.
That's bit 1, right? If I'd ended it with 4, it would have been bit 2. Okay, so all right. So now the question comes, where's their rising edge? Right there. Okay? And what time did the rising edge occur at? Right then. Okay? And now, where's the second rising edge?
The next.
Yeah, right there. There's another one. Okay? So the question that we're asking is, what is the time between the two rising edges?
Well, it's a down counter, so we have to subtract
Yeah,
them,
we
right?
got it's a down counter, so we'll subtract it. So if you look at this element here, you will see that it took those two values, took the first one, and subtracted the second one from it. So what did we expect the time difference between the rising edge of bit 1 to the next rising edge to be?
Did we say 2 milliseconds?
Well, 2 was the... let's go back to our what we expected to have happen. Let's go back over to this and say this is the rising edge of bit 1, right?
Right.
And the next rising edge of bit 1 is where?
Oh, at number 6.
At 6. That difference is 4 milliseconds because it increments, which means it goes down, up, down, up.
Right.
So the time difference between bit 0 would have been 2, and the time difference between bit 1 is going to be 4. And let's see what we got. Okay? So now the question here is, what number is it, right? What does that number mean? Okay, in bus cycles, that means 4 milliseconds.
Oh, that makes sense.
Yeah, let's let me see what happened. Let's see if you can figure this out. Okay? What if I were to end this with a 4? What am I looking at now? If I ended the data value with a 4 rather than a 2, let me do that. Copy down to the bottom. Paste. Copy down to the bottom. Paste. What am I looking at?
Are we selecting bit 2?
We're selecting bit 2. Okay, so now let's play the game again. What did we expect to happen? Okay, what did we expect to happen on bit 2? Where's the first rising of bit 2?
4.
4. Okay, there's the first rising. Okay, where's the next rising?
12.
12. What's the difference?
8.
8. Okay, so let's see if that's actually what happened. Okay, so where's the first rising of
Right
bit 2 is there. Let's give that a color. I'll make it that color. All right. Where's the next rising?
The second 4.
Yeah, right there. Okay, this is the next rising. And so how do I calculate the time difference between those two?
Well, since it's a down counter, we'd have to subtract the top one.
This one?
And then subtract the bottom one from that.
Yeah, let's see what we get. There we go.
Nice. And that's double the other ones.
Yeah, double the other one.
I do have a question, though.
Yeah.
When we look at the bit 1 rising edges, the values aren't the exact same each rising edge. Like this one's...
Yeah.
320.
Oh, yeah. And so, welcome to real world, Elise. It's not a very, okay. The variability you're seeing in the data is not a function of the timer, but it's a function of the way in which we created the actual waveform. This is not a very accurate way to measure time. It's close. It's close, but not fully accurate.
Oh, that makes sense. Thank you. That helps a lot.
All right, now go have fun.